Thank you. So, when I think about tests, whether it's automated tests or manual tests, I think of us having a conversation with the software, with the system that we are testing. I'm going to be in the light, thank you. Very important. So here's a nice, simple automated test. We're testing a credit card validator, and we're asking it three questions. We're asking it, do you reject invalid credit card numbers? And the answer is yes, it does. We're asking, does it accept valid credit card numbers with valid security codes? And the answer is yes, it does. And we're asking, does it reject valid credit card numbers with invalid security codes? And again, the answer is yes. This is a conversation. Automated or manual, we're having a conversation with the software. Sometimes the answer is no. Sometimes we're asking, do you do this thing that I expect you to do? And the answer is no. The test has failed. And whether we're running a single test, a full test suite, our entire pipeline, every single automated manual test we have, we really only have two answers here. Either all the tests pass, which tells us our conversation was successful and we are now ready to release. We're good to go. All of the behavior we expected this software to have is there, or it's not. And we've got to go back and try again. The reason we wrote those tests, the reason we had this conversation, is because we want to capture the things that actually matter about our software, about the behavior our software has. There isn't really a middle option here, right? Yeah, some things fail. Maybe. No. The reason we wrote these automated tests is to capture behavior we don't want to change. It's a binary yes or no. And this type of conversation reminds me of another type of conversation I had once. It was an Anmeldung. Has anyone here ever lived in Germany? Yeah, okay, sorry, I should have put a content warning on that for you. This is a beautiful form. This is a bit of German bureaucracy. If you ever move to Germany, you have to fill in this form. All of these fields, you've got to tell them your Geburtsname, your Staatsangehörigkeiten. You've got to give all of the serial numbers of all of your documents. And if you do all of this correctly, you get your Anmeldung. And congratulations, the talk, the conversation went well, you have passed, and you can now live in Germany, which basically just means you get to do more forms like this, if we kind of break it down. If you get something wrong, you get one of these serial numbers on your document wrong, you mistype your Staatsangehörigkeiten or your previous address, then you failed. Someone in a German office will frown at you and you will have to try again. You will have to fill out the form again. It's a very simple binary conversation. Yes, you passed, or no, you failed. And I don't know about you, but I don't like these sorts of conversations. I'd like there to be other kinds of conversations.
See, the thing is, I don't have a microphone. This is working now. The thing is, I am Dutch, so we have something that's like this. But originally, I'm from the Philippines, and our version of the Aanmelden looks like this. Because there's not one form, there's many. The equivalent of, I think it's gemeentezaal or whatever it is, gemeente in Dutch. In the Philippines, it's barangay. And each barangay has a different form, which is a problem. They all generally ask for things like a name or your address or your birth date, but I think that there are nicer ways to ask someone for their address. I think sometimes people just need a little bit of a nudge to stay in the light, perhaps. I think sometimes you need a personal touch. And the thing is, in the Philippines, you don't even have to register with the barangay. You actually can just have a conversation and be like, hey, this is me. I just moved in. Here's where I live. And you really just create this rapport with someone. It's much more on a one-to-one basis, which means that sometimes, like on the upper right, there is one that has a Google form. Sometimes it's physical. You don't know. You're going to have to use what we call descarte. Descarte is a Filipino word, and it comes from the Spanish descartar, and it is usually used in the context of discarding cards, specifically in a game. See, some conversations can't just be fill in this form, yes or no, and give me your details. Sometimes it's something where you kind of have to have a little bit more finesse. Sometimes you have to see what cards are put down before you can respond to it. So, descarte is about having a strategy that adapts. You can have an initial approach, but it's not something that you would necessarily stick to the whole time. It's something that you change depending on what's played. And this leads us to something that we all do. Everyone does it. And it's not necessarily something that we like to talk about at work. Everyone flirts. Flirtation is already rife with this descarte, with this feeling of playfulness that we're bringing into everything, and we also can bring it to work. It turns out that there are a few things that are kind of like preconditions for flirtation, and there's a nice little acronym for it, WRAPPED. You need rules, a certain kind of attitude, a spirit of playfulness, and you need some tension. It's often funny to think of flirtation as something that requires rules, but rules are necessary. We need boundaries, we need consent. I play Dungeons and Dragons games, a few of them every week. And in D&D, we have these things called Fey crossings. They're usually denoted by these magical mushrooms. And when you step into this magical circle, the rules are different. You're no, you're not forcing anyone to step into the circle. But once you're there, the field of play is circumscribed. That initial stepping in is not something you can do for other people. At work and in our daily interactions, we need people to step into that circle with us willingly. So, how do we do that? Well, we can introduce a little bit of play into it by having a ludic attitude. Johann Hausinger is a philosopher who who thought that we have Homo sapiens, and really the thing that separates us from other animals is our capacity for play. So he has this idea of Homo ludens. What we're good at humans is play. Otherwise, something like a pillow fight could actually be pretty violent. The difference is intention and attitude. Your intention is not to hurt. That needs to be clear up front. That has to be spoken out loud in the rules. But once you're there and you're engaging with a ludic attitude, then the real flirtation can happen. The next step is an invitation to play. Sometimes you can do this just with eyes. It's called an invitation because it's not a demand. You're not trying to blackmail someone into it. You're not trying to you're not trying to blame them. You need to know, especially if you're testing, that other people might react differently to you questioning their work. So what you do is you make that questioning an invitation rather than the blame game. It's called an invitation because there has to be a carrot at the end of it. There has to be something in it for them. Andrew Pillane, a friend of mine actually, he wrote that the next factor that's required for flirtation is tension. Just like there has to be a carrot, there also has to be a stick. There has to be something that everyone can lose. Maybe that's something that you are sharing together. Maybe it's different for everyone who's involved in the game. But the tension and metaphor are important ingredients for anything to be engaging and playful and interactive.
Tension is important because tension is risk. The risk of being rejected, the risk of things not playing out perhaps how you might want. And that's interesting to me because we've got a lot of people in this room, probably, who have the word tester or quality in their job title. And how you might describe that, what your job is, what your responsibility is. Many of us would say that our job is to manage risk. How many people here would say that at least in some part your job involves managing risk? A lot of hands going up, of course. Now, it's been pointed out again and again that tests themselves don't manage risk. The best a test can do is highlight a risk. It can show a risk. It can never reduce the risk. There has to be something else. And there's a framework I quite like for helping people think about this. It's 3 simple questions, what's known as the standard question. We ask, what? So what? And then now what? So when we're thinking about a test, our what is the test failed, okay? That's the risk there. Something has happened. So what? Okay? A green light turned red. So what? Well, what that means is something changed since our last test run, right? We wrote this automated test or even this manual test for a reason. To keep an eye on a particular change, on a particular piece of behavior, and confirm that it does not change without us being aware of it. And now it changed. So what? Now what? What are we going to do about this? And if you think about this, there's really only 3 possibilities here. If one of your test cases fails, again, automated or manual, either the behavior changed without you realizing, you introduced a bug, in which case, fix the bug. Or maybe the test got something wrong, in which case, fix the test. Or maybe the test just doesn't make sense anymore. It's no longer relevant, in which case, delete the test. That's the now what. Those 3 things there are how we actually manage the risk, how we reduce the risk. If we found a bug, we fix the bug. That's the risk management part. And I think a lot about that little flowchart there. The 3 options for what we do when we see a failing test. See, the flowchart's pretty simple when you get right down to it. And how we go through this flowchart, because if you think about it, we go through this decision tree possibly hundreds of times a day. If you're doing test-driven development, maybe dozens of times every hour. And it informs how we structure our automated tests in particular, right? If a test fails, we want to know if that actually captures a bug, which means our tests should clearly describe what they're testing. This is where the value of BDD scenarios, it should do this, given when then, clearly explains what is the behavior we're actually testing here. And then we should be able to fix the bug, which means the test should allow us to quickly identify what we need to fix. For unit tests, ideally, I want to be able to zoom in on the line of code I need to fix within seconds, if not a few minutes. But it's also possible the test is a false negative, right? Maybe an ID, the ID of a selector changed, or the color or the position of a button changed. If it's a false negative, my test should be really easy to debug so I can understand if that's the case. Again, our tests need to be maintainable and understandable, just like our production code. And we should be able to fix our tests, which means, again, it needs to be not just understandable and debuggable, but also maintainable. Our software needs to be testable so we can understand what's going on. And if the test isn't relevant, Because that's possible, right? We wrote a test for a piece of behavior, and now we've deprecated that piece of behavior. It's gone. We no longer need this test. Again, we need to clearly understand what the tests are doing. That clear name of the test. What is the behavior we're testing here? And we should be able to delete the test. This sounds obvious, but it means the tests need to be independent. If your test relies on something the previous test did, well, now you can't change it. I think a lot about this flowchart because we go through it again hundreds of times a day in some cases. And it shapes how we design our tests. This informs, like, what does a good test look like? That's the answer. A good test is one that allows us to go through this decision tree as quickly and effectively as possible. But not every test is like this. Not every test has a simple 3 options. Fix the test, fix the bug, or delete the test. Some types of risks that we're managing are different. Sometimes we need to start flirting with risk rather than just going through a flowchart.
So, one way that you can do that is by introducing a spirit of playfulness into your testing. This is in a tool called Obsidian that I really love. It's a note taking tool. And what I like to do is use this table to kind of change up the dynamic, change up the conversation. The thing is, as a tester, especially if you've done consulting and you see the same problems over and over again, we're pretty convinced that we know what the issue is. We know what tests to run or kind of what answers we're looking for. But what if we're asking the wrong question? So, this table is a list of questions for me to ask of myself or of the system or of the people surrounding the application, which is also, they're also part of the system. And what I like is at the top there where it says dimming, that is actually randomly determined. So it rolls like a dice roller on that table and it picks one. And I sometimes get questions that aren't really that relevant, but then I think about why they're not relevant. And maybe I need to question that assumption that it's irrelevant. It's a way to just kind of get out of that creative rut. I was talking earlier about an invitation to play. The thing about the invitation is it requires that eye contact, that thought that I'm seeing you, but I'm also letting you see me. This is kind of like observability. Sometimes there's a funny thing that happens where when you go into a new project, just having a single source of truth and having everything tracking what's happening in the system without even making any changes yet is enough to magically make the system faster and better. It's because everyone's on the same page. It's because everyone is observing themselves and others and responding to those actions in others rather than using their preconceived notions of what they need to do next.
I'm a big fan of chaos engineering. And if you've heard of chaos engineering, you've probably heard of Chaos Monkey. This is a tool built at Netflix. And very famously, what Netflix does is every day, during office hours, of course, when people are actually there to respond to it, they release the Chaos Monkey. It's a little tool that looks at all of Netflix's production infrastructure and it starts turning off random services. It simulates real world failures. So the teams get used to dealing with them. They stop asking, what if this happens? And they start actually having to live with it happening. And I'm often frustrated when people talk about chaos engineering because people talk about how Netflix, they've just turned this on all the time in production, but there is a process to this. There is a discipline to this. See, it starts with running the chaos experiment itself, unleashing the chaos monkey, introducing what we sometimes call the chaos variable. And then, oops,
Sorry, I couldn't.
another
I couldn't help
another
myself.
chaos experiment there. And then when something goes wrong, we learn from the failure. We sometimes do postmortems. We do uh, incident analysis. This is a very small image. It will be in the references at the end, but this is the Etsy debriefing facilitation guide. It's a fantastic guide for how we can learn from incidents, not just fixing the problems, but really amplifying our learnings when things go wrong. As John Allspaw puts it, uh, an incident is just an unplanned investment. You've already paid the cost. Now your job is to make the most out of that. This is how you do it. We learn from these failures, and then we can improve the system resilience. We go through this again and again. And I'm really interested in this point about improving the system resilience, because some people call this bug fixing, right? We brought down this service and the whole platform fell over. None of our users could use anything. We need to fix that bug. I don't necessarily think of that as fixing a bug, because this is where the really interesting conversations happen. This is where we need to talk about the trade-offs. Is this even something that we want to invest the time in fixing? Is it worth the effort? Is it worth the additional complexity we are adding to the system? So when I think about the what, the so what, and the now what here, all of these have these elements of flirting. The what, the running the chaos experiment, the unleashing the chaos monkey, or any of the dozens of chaos engineering tools out there, we need some boundaries there. We don't just randomly kill production services. We need to ask for permission. We need to set those rules up. Again, people talk all the time about how Netflix does this. All the time in production, your first chaos experiment can be on one service or two services, but you need to get that agreement. You need that invitation. As my friend Russ Miles puts it, if you just turn off a random server without telling anyone, you're not running a chaos experiment, you're just making a lot of enemies. So set up those rules. Make this a safe space where you can play. And then you need to actually learn from the failure. Things go wrong all the time. And to do that, we need observability. We need to be able to see what's going on in our systems. If we can't, if we run a chaos experiment and the only feedback we get is that a lot of our customers are very angry at us, we can't really learn very much. We need observability. We need to be able to see what's going on. And then now what? This is the really, really interesting part. Maybe we discover that one of our core systems is a single point of failure. Maybe that means that we're going to invest in breaking it up into multiple services or horizontally scaling, or maybe the complexity of that is actually going to make things worse. Fixes have risks too. As Lauren Hochstein puts it, the eternal focus on preventing this from happening again over reducing future risk is telling. Yes, if something went wrong in the past, maybe we should consider trying to prevent it happening again in the future. But there's a risk that we make things more complex. There's a risk that we make future failures that we hadn't even considered more likely. Every intervention has a risk. We need to balance that risk. We need to play with that tension. That's the really interesting part of this. Not the turning off the server, but the conversations that follow afterwards. And the other great thing about this is whenever I have introduced chaos engineering to an organization, everyone has a really good time. Typically, the first time, this was a team a couple of years ago I introduced it to. And usually the first time we do it, we do a game day. Like it's in the title, game day, right? We had two teams, right? We had the red team. They were the ones turning off the services. We didn't even use Chaos. We didn't even use Chaos Monkey. We didn't use any tooling. We just went into the AWS console and started turning things off. And we had the blue team who were monitoring the system and seeing if they could detect what went wrong, seeing if they could see the impact. The really interesting thing is, after because this was a new practice for this particular organization, I presented the kind of results, the findings, and kind of what we were going to do to the leadership, to the management of this company. And I got two really important kind of responses to that, right? The first was the leadership said, "This is great. We love the work you're doing on improving resilience. We want you to do more of this." And then I had the team themselves coming on and saying, "We want to do more of this because it's really fun." We had other teams coming to us and said, "Could you do it with us as well?" People really enjoy this. There is a ludic element here. There's an element of play. Chaos engineering is fun. And for all we're talking about, chaos engineering and what you might think of as an advanced topic like that, I think we can see elements of this in probably something you're all familiar with, right? You all know the test pyramid, right? I'm assuming at this point you all know the test pyramid. We've got our unit tests at the bottom. We've got these are that might have been, who knows. Again, things go wrong in real life. That's what we got to deal with.
You're just doing it to yourselves now.
Maybe I am. Who knows? Who knows? So we've got our unit tests, right? These are fast feedback. So we want to rely on lots of those. And then we've got our end-to-end tests. These are closer to the user, but they're more expensive, more difficult to maintain, slower to run. So we want a few less of those. That's the basic idea of the test pyramid. But sometimes when you see the test pyramid, it's got this little cloud at the top labeled exploratory testing. I always find this really interesting, right? Because it's the test pyramid, not the test pyramid and a cloud. Like, what's up with that? Like, why is the cloud up there? And I think it's because the test pyramid itself, that's about the stuff we can automate. That's the stuff that we should be thinking about, those three options. Either we fix the bug, we update the test, or we delete the test. But the exploratory testing, that's got an element of flirting and play to it. Think about the what, the so what, and the now what. Well, we do some exploratory tests, and we're going to need boundaries here, right? We probably shouldn't go out and test absolutely everything in the system. It'll take a while. We've got to focus. Maybe we time box. Maybe we pick a particular feature, a particular page. So we do need boundaries. If we've got an incomplete feature, maybe we just don't do exploratory testing on that. Giving a team feedback on a feature that is explicitly unfinished, is that really going to be beneficial for them? So again, we need boundaries, we need agreements about our scope here. And then the so what? Well, we learn things, right? This is where we need to be able to see what's going on. This is where we need to understand that if I press this button, did it cause the CPU and the memory usage of all of our servers to explode? This is where, again, observability and being able to see what's going on comes in. And the now what, again, is the interesting part. Just because we see something that could be a bit better doesn't mean we need to stop the release. Just because we see something that might be misunderstood doesn't mean we need to completely re-engineer a feature. This is where we have the conversation. This is where we manage the risk in a more interesting way. This is where we manage the tension. I think robots.
Those question marks are where we can cause a little bit of tension. I think that as a load tester, there are many ways that we can approach this. I have felt really tempted a few times to walk into a project and be like, right, I've seen this before. You're making really, really unnecessarily complex database calls. It's going to fail at this point. You've done a crappy job. You should fix this. There's no point in going any further, especially not to production. But that's not really going to give me the results that I want. Tension without that ludic attitude or that invitation to play, that consent of someone to enter into this magic circle with me, is just being antagonistic. And a lot of times we run load tests like they're just sequential tick boxes that we just need to check off. They're just requirements to get to production. But that's not the fun of it. Load testing should be fun. Load testing should be responsive. It should say, I'm doing this not because I think you did a bad job, but because I'm just playing with you. And I am working with you. We are working on something together, and I'm right here with you, and I'm not going to let you be in the spotlight on your own. So when we reduce a load test or performance engineering to taking this approach is not really going to cut it. You're going to need something with a bit of a finer touch.
Yes, you will. I read this book, Continuous Delivery, many, many years ago, and it had a huge impact on me and probably, well, realistically, the whole industry. Written by Jez Humble and Dave Farley, continuous delivery is the ability to get changes into production or into the hands of our users safely and quickly in a sustainable way. It's about moving away from releasing software once every 6 months, once every year, which was actually my experience before moving to this sort of way of working, and writing software that can be put into the hands of our users anytime we want to. Maybe even getting every single change we make into production. And that's a practice. This practice of continuous delivery needs a lot of very, very important practices. There's some key principles that underlie it. One of them is building in quality. Having the team take ownership of quality, shifting quality and testing as far left as we can. It means it requires the team to take ownership, not just of writing the code, but of delivering that value to our users. It needs a repeatable, reliable deployment pipeline, which means in order to have this, in order to repeatedly, reliably, and safely get our changes into the hands of our users, we need to automate almost everything. And I've been thinking about this line. It's been a small part of my brain devoted to this one sentence for about a decade now. Because this line, I think, causes a lot of tension. When I've joined organizations and I've tried to help them take on continuous delivery, this is often taken as a threat. Is my job going to be automated? I have seen people look at this line with fear that the almost everything includes their entire job. And thus, continuous delivery, as fantastic as it is for the entire organization, for the team, for the users, is a threat here. But it's that word almost that is important. I think you could write an entire book on what that word almost means. But in the book, Continuous Delivery, this is the paragraph that describes it. Jez and Dave say, there are some things that it is impossible to automate. Exploratory testing relies on experienced testers. Demonstrations of working software to representatives of your user community cannot be performed by computers. But the list of things that cannot be automated is much smaller than many people think. And that's the tension. See, the tension. Sorry, I just realized I said that. When we talk about automating almost everything, it's not about picking someone's job and saying, we're going to automate that. It's about making sure the people are doing the things that people can do really well. The people are doing the interesting problems. I checked the agenda for TestCon, and there are 14 talks with AI in the title. Okay, This is not one of them. Um, Ever since ChatGPT sort of took over the world and mostly conference agendas, um, a lot has been talked about what ChatGPT and the other LLMs are going to automate. And there's one I screwed up the and I think in terms of like, well, what should it be automating, right? We're always doing something. We're always doing a thing. There's the what, we do a thing. There is the so what, we see a thing, we see the result. And then there's two possibilities here, two possible outcomes. Either we have a simple problem, something we can follow a flowchart for, or it's an interesting problem, something people can do, something people not just can do, but they should be doing. I want people to be doing the interesting problems and computers to be doing the simple problems. This tweet stuck with me. That humans doing the hard jobs on minimum wage while robots write poetry and paint is not the future I wanted.
Well, the question is what we should be doing, what kind of work we should be doing. That almost that you spoke about, that's not something that you can automate. You know, when you, for example, want to invite someone to do a talk with you, you could do it in much less successful ways, especially when you have very different styles. One of you is very organized, although they screw up sometimes, and the other is very chaotic. That almost is something that we are good at. That's the almost that we are hired to do. That is the value that we provide to a testing team or just to any team in general. We need to work on the interesting problems, not the computable ones. The computable ones are the ones that can be automated. So why are we doing that? Why are we just trying to make our own work less fun? This industry is one of the most exciting things. Like, I don't know, I get really interested by seeing these lines when I'm running a load test and it's just going higher and higher. Sometimes we forget that that's the feeling that we're doing this for. And if we treated it as if we were just robots, then what's even the point? You're just making enemies. Instead, we should steer into that flirtation. We should steer into the fun, and we should flirt with risk.
Thank you. That's the end.
Ooh, we have questions.
We do
Did
have
we read
questions.
Yeah, thank you for your presentation. I think it's the first time I am left in chaos, and that's what the intention was. So that's great. Is chaos engineering still effective even when the organization does not have a good post-mortem culture to learn from mistakes?
Great question. Short answer, no. Longer answer, it's a great way of building that postmortem culture.
Yeah, I was going to disagree.
Go on.
I think, no, I think that is such a good opportunity. You build the culture, you start it. You have to create that safe space. I think it is absolutely, it's like low hanging fruit. You start there, you have to give them an example to follow, and that's how you
Yeah.
build the culture.
Yeah, it's the way you build it up. Exactly. It will be challenging if you don't already have a good postmortem culture, but it can be a fantastic first step to building that.
Okay. Someone in the audience is curious about the name of the Chaos Monkey tool.
That's a good question.
It
I
is
don't.
Chaos Monkey.
Chaos Monkey.
Yeah, there's a bunch of other ones. There's Litmus Chaos. K6 does it. I mean, that's like a plug. But K6 does both chaos engineering and fault injection. Gremlin used to be a good one, not open source. I don't know if it's still up though. Yeah, Litmus
I
Chaos.
think it is. Yeah. So Netflix originally had a suite of monkey themed
The Simian Army.
the Simian Army
Yeah.
of monkey themed chaos tools. So they had Chaos Monkey, which turned off individual services. They had Chaos Gorilla, which turned off all services within a given cluster. They had Chaos Kong, which turned off entire availability zones. They had Latency Monkey, which added latency. Various monkey-themed tools. I don't know why they. I mean, you kind of get the idea. Like monkeys are always like pulling on cables and things, I guess.
We could actually also answer that last question. Sorry, I'm doing it out of order.
Go on.
The abstract mentioned fault injection. Yeah. Any specific examples of tools or practical experience? Yeah, I wrote the abstract. Steve didn't get the memo because I wrote it. Fault injection, it is, I think I would classify it as like a specific part of chaos engineering. It's not all of it. The things that you were talking about, like injecting latency, that is also fault injection. It's also things like having a listener wait for a specific call and then giving it a different answer. All the tools that I mentioned, Litmus Chaos, K6, Gremlin, Chaos Monkey, those things would also inject some sort of fault. Did you want to add anything to that?
No, I think that was a very good answer.
Okay. What do you think of load testing together with Chaos Monkey applied?
I wouldn't start with it. I'd start small.
Yeah.
Normally, yeah. Go on.
You don't need to always test or do chaos engineering at the maximum possible scale. You can start small. You can even start in a staging environment against a couple of services. But in general, I love to do to layer on different types of testing, right? So you can be doing chaos engineering or load testing while running maybe synthetic monitoring or other types of testing on top of it to see how one impacts the other. Because otherwise you tend to be looking at one specific metric, maybe the P95 of a particular endpoint, but maybe other things are going wrong. So yeah, more challenging, but it can be fun.
I also want to say, I think load testing is kind of overrated. You know, running a test with thousands of users, like virtual users, that's what people jump to. But also really valuable is running a handful of users continuously. That's why we had the continuous delivery slide. I think a key principle of chaos engineering is keeping the blast radius small. You don't start out by, exploding the entire quarry. Like, you start small and you build up from there.
Yeah, I heard some snarls from the audience, so there are probably some performance engineers who are hurt by now.
I mean, that's what we want to do, right?
Right. Can this be applied to application testing, or is it strictly for operations teams that keep up service? If so, how?
So I mean, chaos engineering in particular, obviously does very specifically take the view of understanding like the system as a whole, with, including the running services, the infrastructure, and all of that stuff. That said, the general approach of flirting with risk, right? The general approach of having more interesting conversations is something that applies very broadly and not specifically to the, let's say, the shift right, the operations side of things, as much as I dislike the strict separation.
Yeah, I agree. Let's go to good question. How do you set the boundaries in a large corporate environment where turning off a service can impact tens of stakeholders, teams, internals, and externals? This is why rapport is so important. Like, I know that there's like a bit of a gimmick to the to the presentation, but it's true. You really do need to establish that relationship, because if you come off really antagonistic, you're not going to be able to do your job, and that's the reality of it. You need to be there. I mean, the systems that we're tuning include people, and if you don't tune for the people, then you can't tune the system.
The keynote this morning was about making friends. I find it a little bit odd, but that's a point that needs to be made. I mean, we're not enemies. Like, we are working towards the same thing, right? So yeah, build positive relationships with the people you're working with. If that's news for you, then yeah, good luck. Have fun.
Okay, cool. Well, that's it for now. Thank you very much.
Thanks, everyone.